The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today we're going to go on and take a look at section 7.5, simplifying complex fractions. Before we do either of you have any questions you'd like to look at?
I do have some.
Okay.
And this is for section 7.3.
All right, give me just a minute here to get into web assign. Okay. Here we go. Okay. You said 7.3, right?
Yes.
Okay, looks like what number? Starting on number 26.
Number 27.
27. Okay. All right.
Oh, and 26 too, you're right.
Yeah, I don't know that I'm going to take time to do all of them that you've got there.
No, you're fine. Just
Okay.
the ones, that one is fine.
And then if you still have questions, maybe.
I could get,
Okay.
yes.
All right. So this is from section 7.3, number 26. Find the least common denominator of the pair of rational expressions. So we've got 5x minus 6 over x squared minus 5x minus 6, and then 2x plus 1 over x squared minus 36. So factoring the first denominator, we get that. Factoring the second denominator, we get that.
Yes.
So what do we need for our LCD? We need an x minus 6, an x plus 6, and an x plus 1. So it looks like your problem was in factoring that first denominator.
Yes.
Yeah, and that's a tricky one.
That was a really tricky one.
Yeah. Okay.
Okay, got it. Thank you.
What now?
Let me see. I would like to get number 27.
27. Okay. Find the LCD of the pair of rational expressions. So basically the same idea as the previous problem. Yeah.
Oh, got it. Yeah. Okay.
All right, this one is that. This one is that. So you need 3n plus 5, n plus 6, 2 factors of it.
Okay. Oh, okay. Now I get it.
All righty.
Yes. Thank you.
Yep. Anything else?
One more. I had a question on it. Was on 30.
Okay. Build the following rational expression into an equivalent expression with the given denominator. So basically what I need is I need to multiply both the bottom and the top by x plus 4. So my new numerator is going to be 9x squared plus 36x. And so my final answer is going to look like that.
Okay.
Does that make sense?
Yeah, so basically I just multiply that x plus 4 in both sides, right?
Yep, top and bottom.
Oh, okay. Let me just screenshot. Thank you. Got it. Thank
All right.
you.
We good to go?
Yes.
Abel, any questions before we go on?
No, I'm good.
Okay, then let's go on. So we're going to take a look at 7.5, simplifying complex fractions. So first of all, let's look at the difference between a simple fraction and a complex fraction. A simple fraction just has a quantity in the numerator, just like a single number, and a single number in the denominator. So that's a simple fraction, or 2.5 over 4 3/8. Well, actually, no, maybe that's not a simple fraction. How about x plus 7 over y? Well, that's a simple fraction. Well, what makes a complex fraction? Well, where you've got an additional fraction in either the numerator or the denominator. So let's say I've got 1/2 divided by 4. That's a complex fraction. Or 2/3 divided by 5/9. That's a complex fraction. Or x over y plus 1 over z all over 2w. That's a complex fraction. So with a simple fraction, you just have the one big fraction. Now, why didn't I do that? Because that would have been a improper fraction over an improper fraction if I'd taken it further. That's why it wasn't a simple fraction. But these complex fractions, there's more than one fraction, not just the big one, but maybe additional in the numerator or the denominator or both. What we're going to do is we're going to take complex fractions and turn them into simple fractions, and then if we can further reduce them, we will. We're going to start out with the I'm going to say the easiest examples first. Let's say we've got 2/3 divided by 3/4. So we have a single fraction divided by a single fraction. This is still a complex fraction, but this is equivalent to 2/3 divided by 3/4, right? Because among other things, this is a division symbol.
Mm-hmm.
But dividing by a fraction is like multiplying by its reciprocal. Okay. So now we're multiplying, and let's see, I can't do any reducing. So my final simple fraction is 8/9, right?
Yeah.
You okay with that? All
Yes.
right. Sorry, my phone's buzzing. Move it away there. Let's take a look at this one. Let's see here. N over 8 divided by 1 over n squared. So this is a complex fraction, but that's equal to n over 8 divided by 1 over n squared, which is n over 8 times n squared over 1. Nothing reduces, so I've got n cubed over 8. You okay with that?
Yes.
Now, this method works when you have a single fraction divided by a single fraction. But now let's look at some other things where that method doesn't work, at least not initially. Let's say we've got 2/3 minus 5/2 over 2/3 minus 3/2. Okay. So we've got more than one fraction in the numerator and more than one fraction in the denominator. So what we're going to do now, we're going to find the LCD of all the little denominators. Okay. So what's the LCD of 3 and 2? 3 and 2. It would just be 6. All right.
Mhm. Yeah.
Oops. Let's see, this was 2/3, I think. Yeah. Now, what I'm going to do, I'm going to multiply the whole complex fraction, the whole mess, by 1. But my 1 is going to be written as the LCD over the LCD. And the reason I'm putting 6/1, 6/1 is to help remind you that this 6 is in the numerator of the numerator, and this 6 is in the numerator of the denominator. In other words, it lines up straight across like that. Okay? Now, I'm going to distribute. So here we go. I'm going to take 2/3 times 6/1, which would be 12/3 or 4. Okay. So far, so good.
Yes.
Minus 5/2 times 6/1, which would be 30/2 or 15. Now we're going to the denominator, 2/3. What the heck just happened? That was interesting. Hang on. Let's see here. I must have touched the wrong thing here. I'll go a little more carefully. 2/3 times 6/1, which is 4. Okay. Minus 3/2 times 6/1, which is 9. Any questions so far?
Mm,
And I'm not done. So but I'm waiting to make sure you're okay.
I'm good to go.
All right. Abel, you good? I guess so. Silence means you're good. Okay. 4 minus 15 is -11. 4 minus 9 is -5. Negative divided by negative is positive. Final answer, 11/5, which is a simple fraction. Okay?
Yeah.
Good to go on?
Yes.
2/x minus 1/3 all over 2/3 plus x over 5. So the LCD of x, 3, and 5 would be 15x. Are you okay with that?
Okay, you multiply the denominator. How do you go with the 15?
I've got an x, a 3, and a 5.
Oh, okay.
All right. So now I'm going to multiply by 15x over 15x. And I'm going to distribute. 2/x times 15x over 1 is going to be 30, because the x's will reduce out.
Got it. Yeah.
minus 1/3 times 15x over 1, which is going to be 5x. Okay.
Yes.
2/3 times 15x over 1 is going to be 10x. Plus x over 5 times 15x over 1 is going to be 3x squared. Now, I can factor a 5 out of the numerator and an x out of the denominator, but it gets me nowhere. So I'll just go back, oops, to that answer. But I went through this step just to see if there was a common factor I could reduce out. Alrighty.
Yes.
How about this one? 10 over n minus n over 4 all over 8 over n. So the LCD would be 4n. Okay with that?
Yes.
Ten over n times 4n over 1 would be 40. Minus n over 4 times 4n over 1, which is n squared. Okay.
Yes.
In the denominator, 8 over n times 4n over 1 is 32 because the n's reduce out. I can't do anything with that, so there's my final answer. Everybody doing okay?
Yes.
All right. What's the implied denominator over the -2, or excuse me, under the -2? What's implied down below the 2's?
A 1?
Yeah, just ones, right? Okay. And we don't need them there, but just a reminder. In other words, this 2, oops, this 2 is not a denominator. So the LCD is going to be 5.
Yeah.
Okay. Three fifths times 5 over 1 is 3. Minus 2 times 5 over 1 is 10. Two fifths times 5 over 1 is 2, minus 2 times 5 over 1, which is 10. 3 minus 10 is -7. 2 minus 10 is -8. Negative divided by negative is positive. So final answer, 7/8. Okie dokies?
7.
Not yet. Okay.
Got it.
Again, you other two, if I'm going too fast, speak up, let me know.
Okay.
All righty, how about this one? 3/4 plus 1 over y divided by 5/6 minus 1 over y. Careful, what's the LCD of 4 and 6? Just 4 and 6.
Wouldn't it be 24?
Minus 3 or multiplied by 3, right?
Okay, what? So the question is,
2 squared multiplied by 3, which would be what, 4 times 3, 12?
yes, but and now since there's also a y, it would be 12y. So we've got 4y 6. 4 is 2 times 2, 6 is 2 times 3, so you need 2 2s, a 3, and a y, 12y. Everybody okay with that?
Yes.
All right. All right, now, so I'm going to multiply by 12y. Oops. Let's try that again. 12y over 1, 12y over 1. So 3/4 times 12y over 1 would be 9y, because the 12 and the 4 would reduce down. Plus 1 over y times 12y over 1, which would be 12, because the y's would reduce out. In the denominator, 5/6 times 12y over 1, 6 over 12 over 6 is 2, so we get what, 10y, and then minus 1 over y times 12y over 1, the y is reduced and we get 12. Okay, well, I can do this. I can take a 3 out of the top and a 2 out of the bottom, but that doesn't get me anywhere. So there's my final answer on that one. All right. Good to go on?
Yes.
1 over x minus 1 all over 1 minus 1 over x minus 1. So now the LCD is x minus 1, because you've got what, this denominator, and the implied 1 denominator there. Okay.
Mhm.
So I'm going to multiply by x minus 1 over 1 and x minus 1 over 1. So 1 over x minus 1 times x minus 1 over 1, the x minus 1's reduce out, and we just get a 1. Then in the denominator, 1 times x minus 1 over 1 is just x minus 1. And then minus 1 over x minus 1 times x minus 1 over 1, which is 1. So then I've got 1 over x minus 2. That's all there is. And we are through with that particular problem. righty?
Yes.
Let's see here. Let's do this one. B squared minus 81 all over 18a squared. Let's make that a little bit shorter. And then that whole thing over, where did it go here? 4b minus 36 all over 9a. Okay, now, is this a single fraction over a single fraction? Yes, it is. So we could do that first method, or we can just find the LCD and do it that way. What do you want to do? You want to do it the first method or the second method? I don't care. Decisions. The clock is ticking. What are we going to do?
The simple fraction, that would be, I would do the easier one. Do the easier one.
Okay, all right. So this is equal to but again, you've got to recognize that it's a single fraction over a single fraction. So if you're nervous about it, just go the other way and your LCD would be what? 18a squared. In fact, we'll go back and do it that way in a minute. But everybody follow what I did? Took that and wrote it like that and then multiplied by the reciprocal. So now I'm going to take that and I'm going to factor everything. So I've got b plus 9 over or minus or times b minus 9 over 18a squared times 9a over 4b times 1 minus, wait a minute, hang on, I can't read my own writing there. That is 4b minus 36. So we're going to take out a 4 and have a b minus 9. There we go. There we go. And this is an a squared. Why do they put 9s and a's in the same problem? I don't. Okay, here we go. That and that will reduce. That and that will reduce. That and that will reduce. So in the numerator, I've got b plus 9. In the denominator, I've got 2 times a times 4, which is 8a. Let's see here. Any questions about that?
No.
All right. Here comes another one. 2a over b. Oh, did you want me to do that other one, the way where you find the least common denominator and do it that way?
Yes, please, just to have the other.
Yeah, okay. I know I said I'd do it and then I forgot all about it. All right, let's see. So b squared minus 81 over 18a squared, and then 4b minus 36 over 9a. So the LCD would be 18a squared. Are you okay with why that's true?
Isn't it because 9 goes to the 18 too?
Yeah. Because this would be 2 times 3 squared times a squared, and this would be 3 squared times a. So you got a 2, a 3 squared, and an a squared. So basically 18a squared is the LCD.
Okay.
Okay,
Yes.
b squared minus 81 over 18a squared times 18a squared over 1. The 18a squareds would reduce out and you'd have b squared minus 81. So in other words, on top, that happens. Okay. On the bottom, 4b minus 36 over 9a times 18a squared over 1. 18 over 9 is 2. A squared over a is a. So now you've got 4b minus 36 times 2a, which would be 8ab minus 72a. I think that's right. This was 2a, so 8ab minus 72a. The numerator factors into b plus 9, b minus 9. The denominator, I'm going to take out an 8a and have a b minus 9. And those cross out, and we have that, which is the same thing we had there. All right with that?
Yeah.
Okay. How about this one? How are we doing for time? Ah, we got time. Lots of time. It's Friday. Nobody wants to do anything but just sit around and do math, right?
Mhm.
Oh, come on, lie to me. Make me feel good. Say yes. This is the best part of our day. Not going there, huh? Okay, fine. I tried. All right. What's the LCD here?
X squared.
X to the third. Excellent. Or
X
X
to the third.
cubed. Sure. Okay. Two over x cubed times x cubed over 1 is 2, because the x cubes reduce out. Minus 2 over x times x cubed over 1. X cubed over x is x squared, so we get 2x squared. So minus 2x squared. Four over x times x cubed over 1. X cubed over x is x squared, so we get 4x squared plus 8 over x squared times x cubed over 1. X cubed over x squared is x, so we get 8x. But I can factor a 2 out of the top and a 4x out of the bottom. I could factor the top even further and write it as this, because that's the difference of two squares. But that additional factoring doesn't get me anywhere, because all I'm going to be able to reduce out is the 2 and the 4 to a 1 over 2. So I think what I'm going to put as my final answer, I'm going to make some room over here for it, is going to be basically, I'll just back to, oh no, that's not right, because I did get rid of something. It's going to be what? X, 1 minus x squared over 2x times x plus 2. So basically this, and I suppose you could leave it factored. You know, it's kind of, again, it depends on what you're going to do with it next. Did I get you completely confused there with all those different options?
Yes.
Well, excellent. That was my goal.
Okay, so we need to factor it, right? From
Well,
the 2.
you want to factor it as much as you can so that you don't miss something you could have reduced out.
Mm,
But factoring this didn't get me anywhere, but I was going to try it anyway.
okay.
But then when it didn't do any good, it's like, well, I'm going to reduce the 2 and the 4. And then I could leave it like this, or I can go back. Well, I could leave this multiplied together. It's, you know.
So if we choose the first answer, it would be wrong, right? Because we have to factor the x square, that one.
Well, you have to get rid of the 2 and the 4.
Yeah.
You have to reduce that down. But whether you
Okay.
leave this like that or x plus 1 or 1 plus x 1 minus x, either way is fine. But you've
Okay.
got to reduce down that 2 and that 4.
Okay,
So you'd have to take it to that next step.
that makes sense.
Okay, good, because that's my story and I'm sticking to it. All right, let's take a look at this one. 1 minus p plus 2 over p all over 6 over p squared plus 1 over p minus 1. What's the LCD?
P squared.
Square.
Excellent, p squared. So 1 times p squared over 1 is p squared. Minus p times p squared over 1, which is p cubed. Plus 2 over p times p squared over 1, p squared over p is p, which is plus 2p. Denominator, 6 over p squared times p squared over 1, p squareds go, and you're left with 6. Plus 1 over p times p squared over 1, p squared over p is p, so you're left with p. Minus 1 times p squared over 1, which is p squared. Okay? So now what I'm going to do, I'm going to take the numerator and write it in descending powers. I'm going to take the denominator and write it in descending powers. Okay. I'm going to factor out of the numerator negative p, which gives me p squared minus p minus 2. I'm going to factor a negative 1 out of the denominator, which gives me p squared minus p minus 6. So far, so good. Okay, so far? Not yet? Okay.
Yes.
I
Right.
have a question. How
Yeah.
you got the negative piece? Oh, yeah, I got it. Oh, you
The
just,
top?
yeah, you just fix them. Negative p is, to the third plus p to the second plus 2p. You just put them in order, right?
Yes.
Okay, got it.
Okay, now I've got a negative divided by a negative outside.
Mm-hmm.
So that's going to be a positive. Okay.
Mm-hmm.
So now I've got a positive p on top and I can get rid of the one on the bottom, right?
Yeah.
Okay, now I'm going to go to the next page. P squared minus p minus 2. P squared minus p minus 6. And now let's see if I can factor things. Let's see, that's going to be a p and a minus 2 and a plus 1. That's going to be a p and a minus 3 and a plus 2. But nothing factors. So I could use that answer, or I could use that answer, or I could use that answer. In fact, the author has this one. But again, I pulled it apart just to make sure, because maybe, these might have had a common factor once I factored them. And all righty.
Yeah.
Okay, well, that's all I've got for you today. I've tortured you enough this week, I think. I'm going to go ahead and stop the recording. I will be back at 1:15 with an office hour.